Hello and welcome back. We're going to get into the surface area of prisms and cylinders. But before we get into that, which is one of the main things that we're doing with this whole unit, is calculating the surface area of polyhedrons. Before we get into that, I need to teach you about polyhedrons. So we're going to go over some quick vocab. This won't take very long though, but it's kind of, I usually split this off into a second day, a separate day, like a shortened Wednesday, just to talk about vocab and some cool things about polyhedrons. But for the sake of brevity, we're just going to move right on, and I'm going to combine it just into one, 2 days basically into one here. So first thing is a polyhedron. If we look at the word poly with the Greek root word means multiple, like polygamy, multiple wives, or polytheism, right? Belief in multiple gods. So just like a polygon as well, right? So poly just means multiple, and hedron means face. So a polyhedron is a geometric shape that has multiple faces. So what is a face of a polyhedron? So a polyhedron, like this cube here, has multiple faces. So the face is going to be one of the two-dimensional flat surfaces that is made on the figure here. So this would be called the front face. There are 6 faces on a cube, right? There's 6 sides of a cube, or a dice is another way. If you have a 6-sided dice, right? This is the front face. The one in the back is called the rear face, or the back face. So those are the front and the back. And then we have the left face and the right face. Okay, so left, right, front, and back. And then you can probably guess we call that the base. And this would be called the top face. So we have the top face, the bottom face, the left face, and the right face. Okay. And then we have the front face and the back face, or the rear face. So those are the 6 names that we call them. If you're used to drawing diagrams for blueprints, like for engineering or architecture, you typically draw a picture of a diagram and a blueprint, and from 3 different views: the front view, the top view, and the right view, or the left view, but typically it's the right view. It's the same idea here. We've got our top face up here, our front face, and then our right face. We also have the left face, the back face, and the bottom face. All right, so those are the faces, and so polyhedron has multiple faces. Then we have vertex. So a vertex, just like a vertex of an angle, is just a point. So all the points that are on the ends that make up the cube are the vertex, or the vertices, if we're talking about plural, more than one. The edges are just what you think they are. Those are the segments that are made up by connecting all the collinear points that exist in between the vertices. So we connect those give us our edges. So I got our vertex in blue, edges are the green, and then our faces, like the front face here, are going to be in red for the whole thing today. All right, next thing we need to talk about is the difference between a prism and a pyramid. So when we're talking about prisms, first thing we need to do is define the base. So which one is the base? Now the base is not always on the bottom, and this might be a little tricky, but the base is not always on the bottom. So in order to be a base, and when we call a base of a pyramid or a prism, we're talking about a specific side. Now sometimes it can be more than one, so let me just get into it real quick. So in order for it to be a base, it has to have a parallel base to it, or a congruent base that's on a parallel plane. So for instance, the triangle here would be the base of this triangular prism, and we name it by its base. So it's important to decide, because we got lots of different faces. We've got the triangle on the bottom, we've got a rectangle on the side, a rectangle in the back, and a rectangle in the front, and then a triangle on the top. So which one is the base? Is it the triangle or one of the rectangles? Well, the reason it has to be the triangle is the base of a polyhedron has to have another base, unless it's a pyramid, on a parallel plane that's congruent. So notice it's the same triangle on the bottom as it is on the top. And so that tells us that the base has to be the triangle, okay? And the rectangles going around it are actually the lateral area, not the bases, or the lateral surfaces. So if we look at this rectangle on the right here, and I move the rectangle over here, is there another rectangle on a parallel plane over on this side? I know that was pretty cool. It was hiding there the whole time. So no, there's not. And for the same reason, I don't have them all done, but I can't move this left face to the back because there's not another one in the back. And I can't move the back one to the front because there's not another rectangle that's congruent and on a parallel plane there. So we know the triangles have to be the base of the polyhedron. So we call this a triangular prism. And it's a prism because it's got two parallel and congruent, or two congruent bases on parallel planes, just like we have there. So that's a prism. Here we have a square prism, which is also known as a cube. Now on a cube, which one is the base? Well, technically any one of them could be the base, right? Oh, I don't think I did it on this one, did I? No, I didn't, but you get the idea. So the bottom face and the top face are congruent and they're on parallel planes. The right face is on a parallel plane and congruent to the left face, and the front face and the back face are also. So technically any one of them could be the base of the cube, right? If you roll a dice, it doesn't matter how it lands, it's always going to land on one of the flat sides, and there'll be a parallel and congruent side that's directly above it, right? So on a square, when we have ambiguity, or a rectangular prism as well, we just typically call the rectangle or the square that's on the bottom, we call that the base, okay? So next thing is a pyramid. So if we know what a prism is, for the same reason that this is a triangular prism and not a rectangular prism, right? The same thing it applies for a pyramid, but for the pyramid we no longer go to a congruent and a congruent base on the parallel plane, but we go to a single point. So let me pull that up here. So that's not that hard to see. So now with the red part, this is a pyramid, so it's a triangular pyramid. So it's still called triangular because it has a triangular base, but then it goes to a single point on the opposite side. All right, so then with a square prism or a cube, right, a square pyramid is just going to go to a single point on the top, right, on the parallel plane, a single point there, right? So we still have a square base, but now instead of going to a congruent square on the parallel plane above it, it's going to a single point. All right, so here's some examples of prisms. So notice on all these prisms, we have parallel bases. Oh, this is so much fun. So here we also have one that's on a parallel plane, congruent base. Now with this one here, because it's a rectangular prism, do you notice if we did the front face, that would be parallel and congruent to the back face, and the right face is parallel and congruent to the left face, just like a cube over here, right? So technically any one of those sides could be considered the base. So with a rectangular prism, we just default to the bottom. Whichever one's on the bottom is the one that we're going to consider the base. All right, here we have another one. Okay, so I guess we'll name them as we go. So this one, our base, is a triangle, so this is called a triangular prism. This is a rectangle, so that's a rectangular prism. This is a square, so it's a cube. Yeah, we call that a cube. And then here we have a pentagon, so this is a pentagonal prism. And notice the pentagon is on a parallel and congruent base with this one, right? So, but that's how we know it's a pentagonal prism. If we took one of the rectangles and we pulled it to the parallel on the opposite side, it doesn't match up. So this cannot be a rectangular prism. It has to be the pentagonal prism. Here we have 6 sides, that's a hexagonal prism, and if you notice here, it's the exact same parallel. That is so aesthetically pleasing to be able to do that. I can't tell you how long this took to put all this together, but it's totally worth it. This is fun. Anyway, so yeah, this is a hexagonal prism, and it's got a congruent hexagon on a parallel base, parallel plane right above it. All right, pyramids, same thing, but now notice we're going to a single point on the top, right? So here we have our square. So this would be called a square pyramid. And I don't know if I did it, but no, I didn't. If I raise this up here, I could draw a prism right above it, but it doesn't go to another congruent rectangle. It goes to a single point. So this would be considered a pyramid. Here we have 6 sides, so that would be called a hexagonal pyramid. 7, if you remember, there's 2 words for that, Greek and Latin. So Greek would be heptagon, and the Latin would be septagon, like where we get September. And then 10 is a decagonal pyramid. Okay, this is called a tetrahedron. It's pretty famous, and we actually use the properties of a tetrahedron for this caltrip, which is used in warfare, or was used in warfare. Now we kind of use them as spikes to deflate tires, like in Mythbusters. So if you use the hollow tubing, it'll actually let the air flow out of it and deflate the tires almost instantly, which is what they found out. It's kind of cool. So anyway, tetrahedron, what's nice about it is that regardless of how it lands, it always lands with a point going straight up. So if it landed on the right side or the right face, then this would now be on the top. If it landed on the front face, that would be on the top. And if it landed on the back face, then this would be on top, etc., etc. Right. So anyway, tetrahedron looks like that. Kind of cool. Would not be pleasant for the horses, though. All right, here we have a square pyramid. So our base is a square. I believe it's square. Yep. And then it's pyramid because it goes up to a single point, not another parallel square above it. And then this side here, this blue length, this is called not the height of the pyramid, but the slant height of the pyramid. And it's the slant height because it goes along the side. So that's very important. The actual physical height would be dropping a perpendicular straight from the top point, perpendicular or orthogonal with the original base. So I could draw that one real quick. So this would be the actual height, which would be coming straight down. And then it would be orthogonal, which means it intersects at a right angle with the actual base, which is pretty cool. So that's the physical height, which we'll use for volume, but this side is called the slant height, which we're going to use with surface area to calculate the lateral area, which is the area of all the triangles. All right, so this is a square pyramid, and over here we have the net. Now the net is a two-dimensional representation of a three-dimensional object. So think of like a globe and a map, right? So a map is representing a three-dimensional object like the Earth, which is totally round, trigger warning, with a two-dimensional flat surface like on a piece of paper. So if we took this three-dimensional square and we unfolded it, it would be this net. It would look like this, right? Where all four of the triangle, the lateral sides, all unfold to give us this kind of a star shape. And if I took this and I cut it out and I folded along the green lines, I could create my square pyramid. Also notice the dimensions that match up. The height of this triangle on the side, that's going to be our lateral height over here. Okay, so polyhedron is a multi-face figures. The bases are congruent polygons on parallel planes. So that's the important part. Whatever the base is, it's got to be a congruent polygon on parallel planes. If it's a prism, but if it is a if it's a pyramid, then it's only going to go to a single point opposite of that, and the sides are all going to be triangles, by the way. All right, so bases are congruent polygons on parallel planes. So this base is parallel on a parallel plane and congruent to the one up here on the top. So that would be our base down there. And again, this is a rectangular prism, so we could have any one of the 6 sides we consider the base. Now look over here. Yeah, it's already highlighted so you can see it, but if you see the one that we might think is the base would be the rectangle, right? The one on the bottom. But if I raise it up here, do you notice how we don't have a rectangle up on the top? So it can't be the base because it's not a congruent polygon on the parallel plane. So there's not another rectangle that's above it. Now there's a rectangle on the sides, but not one directly parallel to it on the top. So that means our base has to be a triangle. And if we put over here, we notice there's another triangle, a triangular base that is on a parallel plane just directly behind it, right? That is also congruent. So it's exactly the same size and it's on a parallel plane. So our base in this case has to be, it's actually on the front face of our shape in its current orientation, and it would be the triangle. So very, very important point. All right, so we're actually going to use the nets to be able to discover the formula, to be able to kind of deconstruct the formula for the surface area of the square prism. So on this square prism, notice that we have our base, which is going to be the square. There's another base up here, so it's congruent in parallel planes, so that's good. Now there are multiple things that we need to know about this this square prism or rectangular prism in order to be able to calculate its surface area. So the first thing we need to know is what is the area of the base. So if this has dimensions 3 and 3, then 3 times 3 is going to be 9. So the area of the base is 9 units squared. The next thing we want to know is what's the perimeter. Well, the perimeter is going to be referring to the distance all the way around the base. And the reason we need to know what this blue distance is because that's going to help us find the lateral area. So look over here at the net. So you can see the base, right? We got our base here. It's the same green base there. Also, that would be the same base up here, right? Okay, and if I took this net and I folded along the yellow lines and I cut around the outside, I could fold it up and to get this. So the surface area of our square prism is exactly the same as the surface area of this net. It's just unfolded into 2 dimensions instead of being 3. All right, so the reason I want to know the perimeter, which is this blue line going all the way around, right? So the reason I want to know that is because that is going to be exactly the same length as this blue line of our net, right? Because all these sides, this side here is going to match up with this side, right? And then this side here is going to match up with this part, that segment, right? And then this segment here is going to wrap all the way around and match up with this segment. So if I want to know the width of this rectangle, because I'm trying to find this lateral area of this big rectangle with the red sides, right? So if I want to know the width of that rectangle, that's going to be the perimeter of the base, which is 3, 3, 3, and 3. So 3 times 4 is 12. So the perimeter is 12. So this length here is going to be 12 wide for our lateral area. Now, if I want to find the height of it, then I'm just going to multiply it by the height, which is the distance between the 2 bases. Remember, they're parallel bases. So how far do we have to go from this base all the way up to this base? It's on another parallel plane. Well, that's going to be a distance of 5. So the difference between the distance between those two is this red length here, which is 5. And notice it's the same for all of them, right? Because they're on parallel planes. So we have a width of 12. I don't think I can, I guess I'll just type it in. So we have a width of 12. We have a height of 5. So how am I going to find the lateral area, or the area of those 4 rectangles all added together? So we have a width of 12 and a height of 5. We just multiply, right? It's a rectangle. So 12 times 5 is going to be 60. So our height we said was 5. The lateral area, that's what LA stands for. Lateral area, which is the area going all the way around the bases, that's going to be 60 units squared. And then finally, I want to find the surface area. So I know this here is 60. Okay. We said our base was 9. And then this base up here is also 9. So how would I find the total, let me color code it real quick. I'm sorry, I'd like have issues where things have to be like exactly right. And I did those wrong. Can you see why it takes me so long to put this stuff together? All right, so how would I find the total surface area of the square prism? So I've got my lateral area, which is 60, right? Those are my 4 rectangles. I got this base on the bottom, which is 9, and this base on the top, which is also 9. So what do? Just add all 3 of them together, right? So 60 plus 9 is 69 plus another 9, which would be 78. So the total surface area is 78. So let's look at our formula. The formula for the surface area of a prism is going to be 2 times the base, right? Because we have 2 bases, plus the lateral area. And the way we find the lateral area is the perimeter of the base. This blue line, the perimeter of the base, is the same as this blue 12 right here, right? Because it wraps all the way around the perimeter. That's the same. Multiplied by the height of the lateral area, which is the distance in between the two bases, which is going to be a distance of 5. So perimeter times height, okay, is the lateral area, 60, plus the 2 bases. And that's it. So this is your formula for the surface area of a prism. Not too bad. So let's look at another example here. So on this one, it's a triangular prism. Remember, the triangle is going to be on a parallel plane to this one. It's exactly the same. So we could call our base the area of that triangle in the back, which would be exactly the same as the area of the triangle in the front, right? Because those two are congruent. Now I moved it to the back so it's not so busy, because we already have a bunch of other stuff going on up here. All right, so first thing I want to do is find the area of our triangles. So notice this, with a triangle, you have to use an altitude, which is a right angle. So look for the right angle, that's our height of 4, and our base is perpendicular to 4, which would be 6. So 6 times 4 is 24. But because we're doing a triangle, the area is half of that. So 6 times 4 is 24, half of that would be 12. So the area of our base is 12. Looks like I did not update this. Alrighty. There's Alright, so the area of the base is 12. The perimeter, which is going to be, okay, so that's 12 right there, right? Okay, so the area of the base is 12. Then when we find the perimeter, that's going to be the distance all the way around. Okay, so that's going to be 6 plus 5, and then notice this 5, that 5 is the same as this one right here, okay? So we got 5, 5, and 6, which is going to give us 16, yeah, 16. So the perimeter, the blue distance, 6, 5, and 5 is going to be 16. And I did not update it, but that's okay, easy to fix. All right, then our height is going to be the distance between the two bases. So the distance between the base and the back and the base in the front here is going to be a distance of 10, right? So that's that 10 right there. So I actually color code it. All right, so that's the 10, okay? And we said the perimeter was 16, so that would be 16. All right, so we've got 16 for the perimeter. That's 6 plus 5 plus 5. We have 12 for the base and the height of 10. Now we have everything that we need. Quite comical. Everything we need in order to be able to find the total surface area. So first, let's find the lateral area. That's the perimeter times the height. So our perimeter is 16 times a height of 10. So 16 times 10 is 160. Okay, so 160 units squared. And then the surface area, all we do is we take our lateral area, perimeter times height, and we add our bases. So if this whole thing here was 160, okay, that's going to be our lateral area, which is the rectangles going around the bases. Then we add the 12 on the bottom, and then we also have 12 on the top, right? Because it's the same area for the base of 12 on the front face as it is on the back face here. So we have 12 and 12, which is 24, plus 160 is going to be 184. Alrighty. Okay, so one more example, which is when we're dealing with cylinders, which just has a base of a circle, right? So we've got our formulas for the circumference, which is our perimeter, right? So the formula changes a little bit because the perimeter of a circle is called the circumference, and then our area is going to be pi times the radius squared. All right, so we have our circle, which is our base, right? It's going to be the same as the base up here, right? Those are the same area. The distance between them, the height, is going to be 8. Our radius is 6 in this case, and our perimeter is going to be found using this formula in the area with this one. So the area of the base, if we have a radius of 6, that's going to be 6 squared, which is 36 pi. I don't think I updated those at all. Okay. Isn't this just magical? Okay, so 36, and we're going to do pi. I'm cheating. Haha. All right, so 36 pi. The perimeter is going to be 2 times pi times the radius, so that would be 12 pi. All right, so I did do some of this right. The height is going to be the distance between the two bases on the top and the bottom, right, on the parallel planes, which is 8. Wow. This is just so magical. All right, then the lateral area is going to be the rectangular area that wraps all the way around our base. So we said that the perimeter was 12 pi, right? So that's this distance here is 12 pi. That's a distance all the way around the circle with a radius of 6. Our height was 8, so all we had to do is multiply 8 times 12 pi. So 8 times 12 pi, I'm just going to put that in the calculator. And when I do, I'm going to leave off the pi. So I'm just going to do 8 times 12, which is 96. So my lateral area is going to be 96 pi. And then to find the surface area, we take our circumference times our height, our lateral area of 96, and we're going to add 2 of the bases. So we said our base was 36. So 2 of those is going to be 72. So 72 plus the 96, which is going to give us a total surface area of 168. Okay, let me double check that. Yeah, 168. All right, so that's pretty much it. So 25 minutes, it took a little bit longer, but tomorrow the lesson will go even faster because I don't have to re-explain all that, and we're just going to deal with cones and pyramids. So the formula changes slightly, and it's actually kind of cool how it changes and how the two relate to each other, but that's okay. I'll wait for tomorrow. So we're on number 1. So on number 1, we want to classify. Let me actually pull up the assignment on my second monitor so I can read along. Okay, so we want to classify the prism at the right. So what kind of a prism? What's our base? Well, if we look over here, we got rectangles and we got these pentagons. Well, the pentagons are on parallel planes, right? And they're congruent to each other. And so it's going to be a pentagonal hexagon. Or sorry, a pentagonal prism. All right, so, and that there's nothing in the answer bank for the classifying the prism, so it's just a pentagonal prism. And the next part we want to know is what's the perimeter, so the distance around the base. Now this is a regular pentagonal prism, so the bases are a regular pentagon, so find the perimeter of the base. So all the sides here are going to be 5. So if this is 5, that means this side's 5, that's 5, 5. Okay, so we got 5 5s, which is 25. So 25 centimeters. Yes, this one's updated. That's good. All right, next, the height is going to be the distance between our 2 parallel bases. So that's going to be a distance of 11 centimeters. The lateral area, it's so nice when it's already done. The lateral area is going to be the rectangle going all the way around our pentagons. So what we need to do is take our perimeter, which is 25, and multiply it by our height of 11. So what is 25 times 11? It's going to be 275. So 275 centimeters squared. Now on this one, they tell us the base. The area of each base is 43 centimeters squared. That way you don't have to like draw an apothem and calculate that. It's just a lot of work. We did that on the assignment 2 days ago, but I'm just giving it to you to save us some time. So 43 centimeters squared, and we want to add 2 of those, right? Because we got 43 centimeters squared on the bottom, and then we also have 43 centimeters squared on the top. So take your lateral area and then add 86 to it. So that plus, well, you could just add it twice if you want. So plus 43 plus 43, which is going to give us 361 centimeters squared. All right, and that should match our answer bank. Yeah, 361. We're good. All right, number 4. What is the shape of our base? So is it going to be the rectangles or the triangle? So on this one, it has to be the triangle because there's another triangle on the parallel plane right above it. It can't be the rectangles because there's not another rectangle that's congruent on a parallel plane. All right, now these are a little bit trickier because we have to solve for the value of x first. Well, if we look up here, we notice that it's a right triangle on the top. That means it's also a right triangle on the bottom. So if we want to solve for one of the legs of a missing leg of a right triangle, we can use the Pythagorean theorem. So on this one, we have a squared plus b squared is c squared. Our c squared is our longest side, that's 5, and then the a and the b are our legs of x and 4. So when I plug this into the formula, it'll be x squared plus 4 squared is equal to 5 squared. So that's 25. Then we subtract 16 from it, which the difference is 9. It's a Pythagorean triple. You probably already know this one. So x squared is 9. When we take the square root of that, we get x is equal to 3. So x is equal to 3. We need that in order to find the area and the perimeter of the base. So it's just kind of making us do an extra step to solve for x first. Okay, now we can find the base. So these are perpendicular to each other, which means we can multiply the base of the base, which is 3, times its height, which is 4, and then divide it by 2. So 3 times 4 is 12. Half of 12 is 6. So this would be 6 feet squared. then our perimeter is going to be the distance, or the distance all the way around. Remember, that's going to be how wide our lateral area is when we unfold it. So that's 5 plus another 7, which is 12. So we have 12 feet. The height is the distance between our two bases. So the parallel bases on the parallel planes here and here is going to be a distance of 6. I know it bothers me too. Oops. There we go. Lateral area. So take your perimeter, multiply it by your height. So we have a perimeter of 12 times a height of 6, which is 72. So 72 square feet. And then to get the surface area, we just add our two bases, which was 6. So we have 6 on the bottom and 6 on the top. So the area going all the way around, the lateral area is 72, plus another 6 and 6, which is 12 more, would give us 84 feet squared. All right, number 9. We've got rectangles and we got triangles. Which one is going to be our base? So on this one, our base has to be the triangle, right? Because on the parallel plane, congruent to it is also another triangle, right? Can't be the rectangles because there's not another rectangle that's congruent to it right above it, right? That's also on the parallel plane. So we've got our triangle. We need to solve for x. We have a perpendicular that's dropped, so we have 10, 6, and x, but the 6 is the distance on the bottom, so I'm probably going to want to adjust this and do 3 instead. So that part there is 3, and then this part is also 3 for the two triangles. So the whole thing is 6. So we got to cut it in half. So we're going to do the Pythagorean theorem. So 10 squared minus 3 squared, that's 100 minus 9, which is 91. Then I need to take the square root of that value, and that'll give me the leg. So 9.54, which will be one of your answers on the answer bank. Looks like I did not update this one. Okay. All right, then for the base, we would take the base, which is 6, times the height of 9.54, and then we divide it by 2. So that's going to be 9.54 times 3, in other words, which is 28.61. Is that one of our answers? Let me check. So number 9, yes, 28.62. Okay, so this should be 28.62, and I bet it's not. Yeah. That's odd. It's like I put it in the wrong spot. Okay. All right, it is, I'm very tired, it is late. Okay, perimeter, so that's going to be the distance all the way around. So we got 10, 10, notice that 10 is the same as this 10 right here. So we have 10, 10, and 6, which is going to give us 26 for our perimeter. There we go. The height is going to be, the height is the distance between our two bases. So from here to here, that distance is going to be 24. And so the lateral area is going to be the perimeter, which we said was 26, times the distance between it. So 26 times 24. And we'll just put that in the calculator, which is 624 inches squared. And that's our lateral area going around the bases. Now to find the surface area, we just add the two bases to that. We said the bases were this 28.62. So I'm going to take the 28.62. I'm just going to go up here and paste it, multiply it by 2, and then add it to 624, which will give us with PEMDAS 681.24, which should be one of your answers. Yeah, 681.24 on the very bottom of your answer bank. Not sure what happened there. Maybe that was if I didn't use the precision. If I used the rounded values instead, then maybe that's what you would have got. I don't know. I'm second guessing everything I do right now. All right, number 16. All right, on 16, first thing we have to do is solve for x. We do have a right triangle, so we're going to do 40 squared minus 32 squared. So it looks something like this. We're solving for a leg, so we subtract. So the hypotenuse squared minus the leg squared. When we do that, I'll just put in the calculator. So 40 squared minus 32 squared. It's going to give us 576, but then we have to take the square root of 576 to get what x is equal to. So caret 0.5. So 24. So x is going to be 24 millimeters. That's the distance on the bottom. For b, that's going to be the area of the base. Now this is obviously a circle for the base, and it's the same base here as we have up here, right? So that's going to be the diameter is 24, so radius is 12. So to find the area, it's the radius squared. So 12 squared would be 144 pi millimeters squared. Should be squared, yeah. All right, the perimeter is the same thing as the circumference. We're talking about a circle, right? So radius was 12, so 12 times 2 would be 24, or pi times diameter, which is 24 pi. And that would be just millimeters, because that's a one-dimensional length going all the way around. So if we unfolded the lateral area to a rectangle, it would have a distance of 24 pi with a height of 32. And so to find the lateral area, we just multiply those together. So what is 24 times 32? And I left off the pi. So make sure we add that to our answer. So that would be 768 pi. And let me make sure that, and it's millimeters squared because we're dealing with area. Just double checking my answer bank real quick. Yeah, 768 pi millimeters squared. Okay, we're good. Then the surface area, we have to, once we have our lateral area going around the bases, we have to add our two bases. And we said our bases were 144 pi. So I'm going to add two of those, which is going to be 288, and still in terms of pi, right? So that's going to be 1056 pi. There you go, millimeters squared. Okay, so that's it. There were definitely a few typos, but for the amount of time that it took pairing all that stuff, I'm surprised I didn't make more mistakes. So we made it. That was about 37 minutes, so not too bad. Tomorrow I promise we'll go faster, and I won't have near as much editing to do, so it'll be easier for both of us. So I will see you guys tomorrow. Good luck. If you guys have any questions on the assignments, most people have just been sending me a private comment on Google Classroom, and that goes straight to my phone, so I can answer that pretty well at any time. So also, you can also email me, of course, but most people have just been sending a private comment on Google Classroom for the assignment that you're uploading, and then I can see your work as well. So it works out pretty well. All right, I'll see you guys later. Have a good one.